The first thing we're going to do on number 80 is let's go ahead and cross multiply so it's more of a linear function. So 2 times 2, r times 2 cosine theta minus 3 sine theta equals 6. The next thing I'm going to do is I'm going to distribute the r to both pieces. So I have 2r cosine theta minus 3r sine theta, and again that equals 6. Let's do some substitution. I know that that is x, so I have 2x right here. R sine theta is y, so I'm going to substitute y. We're going to put this into a standard form, so we want it to equal 0, and I want my x to be positive. So let's go ahead and move this over by subtracting 6. So my final solution here is 2x minus 3y minus 6 equals 0. All right, our goal here is to get rid of the r. Looking at my equations, I need an r squared if I want to do some substitution. So what I'm going to go ahead and do is multiply both sides by an r. So then I have r squared equals 2r cosine theta. Now, I'm going to substitute r squared. R squared is x squared plus y squared equals, I'm going to substitute r cosine, and I can replace that with x. So what I'd like to do is I'd like you to have it equal to 0, so let's go ahead and move this over right here by subtracting it. Therefore, my final equation will be x squared minus 2x plus y squared equals 0. Now, if we look at this equation, x squared and y squared are both positive. Therefore, I have a shape of an ellipse. This last problem here, we really have to dive into our identities, and I wrote down this identity from your identity sheet back in chapter 5. What we have right here is we have a double angle, and there's no double angles in these formulas here. So I'm going to substitute that piece with this piece right here. So 3 times cosine squared theta minus sine squared theta. The next piece I'm going to do is I'm going to go ahead and figure out what I'm going to do here. Now, my only choice, I need an r squared on this side so that I have manipulations of both pieces and their squared pieces. So the only way to get r squared on this side is to actually multiply an r squared on this side, which means I need to multiply an r squared on this side. So when I distribute out, I have an r to the third power. I'm going to distribute both the 3 in and also the r squared in. So I have 3r squared cosine squared theta minus 3r squared sine squared theta. Now, why did I do that? Well, let's look at one of these. If I square both sides, then I have x squared equals r squared cosine squared theta. Therefore, what I can do at this point is go ahead and substitute this piece in right here with an x squared. I can do the same thing with the y's. If I square both sides right here, I have r squared sine squared theta. Therefore, I can substitute this piece and I have minus 3y squared. All right, the left-hand side is going to be a little bit more difficult. Here's what I'm going to do. This is r times r times r. If I take this and take the square root of both sides, I get r equals the square root of x squared plus y squared. So let's only work on this side for a little while. If I substitute each r, I have x squared plus y squared, the square root of x squared plus y squared, and the square root of x squared plus y squared. Now I hope you agree with me when I state that I have the square root of x squared plus y squared, 3 of them. Well, another way to write this piece here is x squared plus y squared. Instead of the square root, I have the 1/2 power. But don't forget, I still have this to the 3rd power. So on the left-hand side, I can state that I have x squared plus y squared all raised to the 3/2 power. And that equals 3x squared minus 3y squared. So now our ultimate goal is to get rid of all of our r's, in which case we did. This truly is an equation that could be your answer, but the best way to write this is to set it equal to 0. So I have 3x squared minus 3y squared, let's subtract this piece over, minus x squared plus y squared to the 3/2 power equals 0. Our goal is manipulations to get rid of my r's and my thetas.